Department of Collegiate and Technical Education, Government of Karnataka, under the LMS system. This video or this session has been carried out. Here we will study the session number 11 on design of fasteners unit 2 for 5th sem automobile engineering, that is the design of machine elements, the subject code 15AT53T. The table of content, simple problems on butt joint and MCQs. Let us directly go through it. So from last two sessions, the 9 and 10, we have just studied the problems on lap joints, single riveted and double riveted lap joints. Now we have some problems on a single as well as on a double riveted butt joint. Just little changes will come here in the butt joint. If it is a single shear, no problem. Same what we have studied in the lap joint will be carried out. If it is a double shear, little variation will come. Okay, let us see and go through it. A single riveted double cover butt joint is made in a 10 mm thick plate with 20 mm riveted diameter and 60 mm pitch. Calculate the efficiency of the joint. If the tensile stress is 100 megapascal, compressive 160 and shearing is 80 megapascal. So first of all, you write down the data given, that is T is equal to 10 mm, diameter of the rivet as 20 mm, and then the pitch 60 mm. And similarly, the stresses are given PT, PC and PS. You mentioned it, that is 100 megapascal is equal to 100 Newton per mm square, 160 megapascal PS 160 Newton per mm square, PS 80 megapascal 80 Newton per mm square. Then he has asked to find the efficiency of the joint. Okay. So one more thing you have to remember, that before starting the problem, you just go through it, what type of joint, whether it is a lap joint or a butt joint. That is very important. Here it is a butt joint with double cover and single riveted. Single riveted means n becomes 1, whereas double cover means shear is double. 2 times when the equation of strength of shear comes, we have to just remember that 2 extra unit is the whatever we have calculated up to this extent, that is n pi d square by 4 tau or fs. To that value just you have to multiply 2 to get the answer. Okay, so let us begin with the problem. So just I have mentioned here, double cover means double shear, and calculate the efficiencies. Okay, so the same equation, that is the equation number 5.11, you adopt it to calculate. Here the 60 is the pitch and the dia is 20, 10 is the thickness, 100 is the tensile stress, tensile stress, and just you calculate the tensile strength. The tensile strength is now 40,000 Newton, tensile or tearing strength. Okay, and it is also mentioned as tearing resistance also. After calculating the tearing resistance or tearing strength or tensile strength, we go for a shearing strength, that is given by PS is equal to N1 plus 1.875 N2 pi d square by 4 into tau. That is equation number 5.13. N1 is 0, N2 is 1 number of rivets. But here double shear is adopted because he has mentioned that in the problem double cover butt joint. Therefore 2 is multiplied instead of 1.875. That comes under Boiler's condition. When you solve for boiler joints, where the joint is made for boiler, then we have to consider it as a 1.875, whereas normally we will take it as a 2. Clear? Therefore 2 into n into pi d square by 4 into tau. 2 into n is 1, pi d square means 20 square by 4 into 80 is the stress. The value is 50,265.48 newtons. The last is crushing. So when you calculate the crushing, the value is N1 and T1, that is equation 5.14 from the design data handbook, and the value is like this: PC is equal to N1 T1 plus N2 T D sigma C, where N1 is 0, N2 is 1. Just substitute, we will get N T D sigma C is equal to 1 into 10 into 20 into 160. The value will be 32,000 Newton. And out of these three values, the least is 32,000 Newton, that is PC. Therefore, the joint will fail in PC. Okay. After calculating the value, we go for efficiency of the joint. The efficiency of the joint is given by least value of PT, PS and PC by strength of the unriveted joint. Strength of the unriveted joint, as already we have spoken in the last problems, that is last session, that is P, capital P is equal to small pt sigma t, where the unriveted means the joint, means the plates are just made up of having holes. That is the pitch distance is calculated. According to pitch distance, we have just hold on the plate. Holes have been made on the plates with the pitch distance of thickness. These two parameters will come into picture here, unriveted joint. Therefore, P is equal to Pt sigma t, which is given by 16 to 10 into 100, the value is 60,000. When you divide both the values, 32,000, that is the least value of the strength, where we come across, where we have shown the least is 32,000 under crushing, because other two values are higher than this. That is tearing is 40,000 and sharing is 50,000 to 65.48. So the least will be 32,000, and just multiplying dividing 32,000 with 60,000 and then multiplying by 100, we will have 53.33%, because efficiency is calculated at a percentage. Next problem will be on the similar type, but the values have been just manipulated or changed. Let us see what are those. So the second problem is like this: a single riveted double cover butt joint is made in 15 mm thick plate with a 25 mm diameter. Rivets with a pitch of 75 mm. Calculate the efficiency of the joint if the permissible shear, tensile and crushing stress are 80, 100 and 160 megapascal. Similarly, he has given everything, just the data has been changed. Just go through it, put it the values in the given data. That is data is equal to 15 mm, and diameter of the rivet is 25 mm, and pitch 75 mm. Then PT 100 megapascal, that is converted into 100 Newton per mm square. PC 160 megapascal, that is converted into 160 Newton per mm square, and PS is 80 megapascal, that is 80 Newton per mm square. So he has asked to calculate directly the efficiency. We go by tearing strength. PT is equal to P minus D into T. It is equation 5.11 of the design data handbook. So the value will be like 75 minus 25 into 15 into 100. The value will be 75,000 Newton. Then we will find the shearing strength of the rivet, that is 1 plus 1.875 into pi d square by 4 into tau, 5.13, where N1 is 1 and N1 is not N1 is 1 and N2 is 1, whereas N2 is 1, and instead of 1.875 we just multiplied by 2. We have taken 2 instead of 1.875. We have taken 2 for double shear, because it is a double cover butt joint. So we have taken N2 is equal to N and 1.875 into twice. Okay, then pi d square by 4 into tau, that is 2 into 1 into pi by 4, 25 square into 80, where we have 78,539.8 newtons. Similarly, crushing is given by PC is equal to NDT sigma C 1 into 25 into 15 into 160, that is 60,000 Newton, and the strength of the joint is the least of the three values, and the least of the three values is 60,000 Newton. Similarly, we have to calculate the efficiency of the joint, that is given by the strength of the unriveted joint, where is given by P into T into sigma T, 75 into 15 into 100, that is 112,500 Newton, 1,12,500 Newton. Therefore, efficiency is equal to minimum or least value of the three strength, that is the minimum strength by strength of the solid plate into 100. 60,000 by 112, 1,12,500 into 100, that gives you 53.33%. After calculating this, we come across MCQs. The basic MCQs here is 3 MCQs given. One is calculate the diameter of the rivet by crushing consideration of the double riveted butt joint if the permissible compressive stress is in the riveted is 160 and thickness of the plate is 12 and the load is 75. So crushing consideration, the problem is like this. It is directly PC is equal to NDT sigma C, where N is 2 double riveted, D we have to calculate, T is given 12 and sigma C 160, and PC is given 75 kilonewton, 75,000. Okay, when you calculate you will get around 19.53 mm. 19.53 mm. So if the tearing efficiency of the riveted joint is 60%, that is P minus D by P is 60%, then the ratio of D by P is 1 minus P D by P. 1 minus D by P is equal to 0.6. Therefore 1 minus 0.6 is 0.4 is the value of D by P. Clear? That is the D equation. Sorry, the solution for this answer is D. That is 0.4. Calculate the diameter of the riveted under shear if the permissible shear stress is 70 and the load is 40 kilonewton with the butt joint double riveted single strap. Butt joint double riveted single strap. The same problem already we have done it. That is the formula will be like this. That is PS is equal to N pi d square by 4 into tau. When N is 2, D we have to calculate, and we have 70 tau and load is 20 kilonewton. Therefore D square is equal to 20,000 into 4 divided by pi into 70 under root is the diameter of the joint. So basically it comes under 13.48 mm. Okay. So after that we have few problems for your homework. Just to go through these problems and solve the problem. It is very easy. Direct data are given. Just go through it and solve the problems. Okay. So that completes our third session. We will meet you in the fourth session.